Hi everyone. So my name is Shirley Nalea Rivera from BSc 3I. My subject for today is dynamics of rigid bodies. So I'll be discussing one of the topics of dynamics of rigid bodies, which is the relative motion, particularly relative motion velocity. So, to further understand this topic, let's discuss the sample problem here. So, example number 1, the wheel of the radius r is 300 millimeters, rolls to the right without slipping, and has a velocity v sub o is equals to 3 meters per second of its center O. Calculate the velocity of point A on the wheel for the instant represented. So as you can see here, above me, you can see the figure of the wheel, which has a radius 200 millimeters and radius 300 millimeters, and we have the velocity 3 meters going to the right. So we also have a value of theta, which is 30 degrees. So in the right corner of this video, we have here a big wheel, which is also the representation or my representation of FBD of this wheel. So we have vector components, which we have theta, which is equals to 60 degrees. Later we will discuss about that. We have VA to O, we have VA, which is located in the middle. We have V sub O. We have the x-axis, of course. We have the y-axis. We have the point A and the point C. So let's start solving this. So to further understand this, let's solve this personally. So as you can notice in our illustration, so here is our illustration. So as you can notice in our illustration, the reference point is the center O. Since the motion is already given, so we can now write um, VA is equals to V sub O plus VA to O. The relative motion of velocity is perceived from the translating x and y axis. The line AO is measured as 200 millimeters, while from point O to C is 300 millimeters. As you can see in this figure once again, the 200 and the 300 millimeters. So let's go back to the solution. So going back to the solution, so we have now VA is equals to V sub O plus VA to O. So now we will write now the angular is equals to V sub O is equals to R. So V sub O is already given in the illustration. If you notice, it's already 3 and the R is 0.3. If we convert the millimeters to meters, it is 0.3. So dividing this, we will now have 0.3, we will now have 10 rods per second. So we have now 10 rods per second. So we have solving for VA to O. We have the R sub O, theta, or the first derivative of theta. And we have now VO is equals to R sub O is 0.2. It's also the measurement or the diameter. R is vector. We have the theta, which is 10. So 0.2 times 10 is equals to 2 meters per second. So that is our V8, 2 meters, and our angular is 10 rods per second. So using the law of cosine, we will now have A squared is equals to B squared plus C squared minus 2AB cosine theta. So we have VA squared. Since we determined that in the problem we are finding the velocity of point A. So VA squared is equals to, which is the B, 3 squared plus 2 squared plus 2, 3, 2 cosine 60 degrees. So where did we get the cosine 60 degrees? So let's go back to our figure. So let's go back to the previous. So the 60 degree is up here because 90 minus 30 here. So I'll just write. So we have existing degree here, 30. So there is the 60 degrees. So we have cosine 60 degrees. So further solving this, we can get VA squared, and now 3 squared plus 2 squared plus 2 times 3 times 2 multiplying by cosine 60, we will now have 19. So we can get an answer 19 meter per second squared. So that's not it. We have to square the both sides. Squaring both sides, we will not get V sub A is equals to square root of 19 is 4.36 two decimal places only, meters per second. So that is the answer for this question, which is the velocity at point A, which is 4.36 meters. That's it for today, and thank you so much for watching, and God bless.